Hey, morning guys, SD here. Had a lot of my new friends on YouTube have been asking a lot of questions about the circuitry and stuff here. We're part of a international group, a bunch of great guys that share information freely with everyone. It's International Alternative Energy Center, or IAC Forum Co.com. At that site we have several different categories, different things that people are working on: pulse motors, solar, you name it, wind generators, everything. There's even a section in there, it's a how-to section that you can go to if you don't know how to read a wiring schematic. We have how-to sections that take you step by step on how to build solid state systems, pulse motors with rotors that move, all sorts of things. So even if you're not electrically inclined, don't know how to do a lot of this stuff, we show you how to do it step by step, and it's a lot of fun. But basically right here we're going to go in. This is a solid state system. This coil has 6 wires on it. This handles this bank of 5. This next one has 5 wires on it, handles that bank of 5 transistors, and the last one back there handles that bank of 5 transistors. All we're coming up to is you have a base on this side of the transistor. You have to orientate this transistor a certain way so you get them set right, but that'll be the base. This is your emitter. Coming off of this fitting right here, or just the body, that's called the collector. And we're coming up with 2 diodes which protect any power from backfeeding into the transistor. These are 5408 diodes that will handle up to 3 amps, 1000 volts. Okay, so that'll protect up to 6 amps worth of power backfeeding into the transistor, so we don't want to go over 6 amp draw. Alright, so what we've done at startup, we can turn the pot down, because I was getting surges, initial surges going into the cell close to 5 amps, so I want to make sure we don't overdrive the circuit at startup. So all I do is slightly turn this pot back down, and let's see how it affects this setup at startup. Okay, went up to about 1 amp, and we've already got production of hydrogen that quick. Okay, so now as it's already started up, I can go ahead and turn this up, and it's going up to about just a little over 2 amps, almost 3 amps. So that's good. Now this meter here will read your frequency and duty cycle of the circuit. You just connect the 2 probes, like you're going to measure like AC power, DC power, but you run the clips up, hook it to one side of your base, and hook it to the other side, your emitter, and that tells you your frequency of your entire circuitry. Okay, so we're running at 2.709 right now, and the duty cycle is 23.6. 23.6 is how long the transistors are staying on. What we want to do is adjust these base resistors. They're 33 ohm half watt resistors right now. We'll probably lower them to 22 or even 10, and that should get the duty cycle closer to 50% on and 50% off. Okay. Now another thing too you can do, you can take these connections and go from each transistor and test them and make sure they're working okay. Alright, now what we did also is I had this power bus here set up when I first initially made this, all out of aluminum, and we were getting uneven readings of temperature readings on each transistor because of the way the current was flowing. So Tin Man and Doug at the site recommended I put a jumper from here to the far end. Well, that was working pretty good, but I was still getting some uneven readings on the middle section. So what I did is this morning I connected these all together, so now it's one complete loop and should get even current flow. Okay, so right now we are set at cell is drawing 18.2. I've got 2 batteries down here hooked in 24 volt mode, and it's at 24.4. Again, the frequency is 2.7, wanting to go down to the 2.6 range, and duty cycle is 23.8. And we're drawing right at just under 4 amps now, it looks like. Let's come over here and take a look at the output. It's not too bad. And here's a little device I made. I went down to Tap Plastics and got, it's a 2 1/4 inch plexiglass tube. You can cut it whatever length you want. I made it 1 foot long and did the same thing with a 4-inch plexiglass and just glued it to a base. They have some adhesive that once you glue it up, that's it. You're not pulling it apart. Anyway, I took this tube and turned it upside down and started putting fluid in from this being the bottom and measured up 250 milliliters each mark. So what I can do now is hook this tube here to this one, and it'll actually measure how much hydrogen production you're getting. Let me set this down for a second and show you. Sorry about the view there, but you'll see the gas flowing down in here and then the water being pushed back up to the tube, and it'll come back out over there here in just a few seconds. You'll see it flowing out of the top. See the water? And once all that's out of there, then the gas will start pumping, and you'll see this cylinder start to rise, and then you can use a timer and time how long it takes you to fill up 250 milliliters or 500 or 750 milliliters or 1 liter. Okay, we're only drawing just it's all just a little about 3.75 amps, and you'll see this slowly start to rise. We're not really pushing this thing hard at all, but it's a pretty inexpensive way to make a measuring device. A lot of guys are using 1 liter bottles. I just think this works pretty good. It's cheap. I did the whole setup for less than 10 bucks. But you'll see it slowly starting to rise here. Let me sit down here. There's your indicator marks right here. I just go off the water level and just watch this rise, so that when the next one comes up, I just sit there and go off the next mark and then start timing it. Yeah, it's real slow. The more I warm this up, the faster that'll go. And when you get done with it, you just take this hose off and kind of lower it slightly down, and this will settle back down. You don't have to lift it up and take it out of there. But there, it gives you an idea how to do all this stuff. Again, if you guys want to come to the site, I'd be more than welcome to let you look around. It's free to sign up, no charges for anything. You just stop by and check out whatever area information you might want to look at. Alright, we'll catch you later on.